Hi class, let's draw one last figure for chapter 4. In this figure we're going to take a look at how do imbalances in heat energy change with the seasons, so winter, spring, summer, and fall. And so a couple of concepts that we need to keep in mind is that there are always going to be heat imbalances across the Earth's surface because there's always differences in solar noon sun angles. If there's always differences in solar noon sun angles, there's always going to be differences in the amount of heat energy received at a particular surface or a particular latitude. Large heat imbalances are going to manifest themselves as large temperature gradients, and the larger the temperature gradient, the more heat energy that's going to be redistributed across the Earth's surface. And then one more point that we can carry this idea through. The more heat energy that's redistributed across the surface, the more energetic the weather is going to be. Okay, so I've picked a couple of locations here. Bismarck, North Dakota, and Miami, Florida. And what we're going to do is we're going to take a look at the average monthly temperature for a couple of months at these locations. Okay, so let's first take a look at the average high temperature in January. We have Bismarck, North Dakota, and that is 21 degrees Fahrenheit. And the average high temperature in January in Miami, Florida is 74 degrees Fahrenheit. And so you notice that there is a difference of 53 degrees Fahrenheit in the average high temperatures between Bismarck and Miami in January. Okay, that's a pretty substantial temperature gradient, and with a pretty substantial temperature gradient, we will have a lot of heat energy being redistributed across the Earth's surface, and that's going to lead to very energetic weather in January. Okay, what I mean by energetic weather is low pressures that are going to be large and deep. Okay, so very low pressures in the center of that low pressure, very energetic. So these are going to bring good storm systems. In the northern plains, certainly they're going to bring some blizzard activity. That's the type of energetic weather that I'm talking about. So large temperature gradients in wintertime will lead to energetic weather, more energetic weather in winter than any other season. Okay. Now let's take a look at summer. If we look at the average high temperature in July in Bismarck, okay, so their warmest time of the year, we're looking at a temperature of about 85 degrees Fahrenheit. Okay? And the average high temperature in July in Miami, Florida is about 88 degrees Fahrenheit. Okay, so you notice that there's only a 3-degree temperature difference in the gradient. So very, very small temperature gradient between Bismarck, North Dakota, and Miami, Florida in the summertime. So there's really, being that there's a very small temperature gradient, there's very little heat to redistribute. So there's not going to be a heck of a lot of redistribution of heat energy in the summertime. Okay, this is going to lead to more boring weather, weaker systems, certainly not the energetic weather that you would see in winter. Okay, so because of the strong temperature gradients in wintertime, you're going to have very energetic weather in winter, and because of the very small temperature gradients in the summertime, it's going to lead to much more boring weather in summertime. And again, what I mean by boring is that low pressures are going to be very weak. You're certainly going to have storms, but they're going to be more convective in nature, whereas the energetic weather of winter, due to the large temperature gradients found in winter, those low pressures are going to be much more energetic and bring all kinds of very interesting weather to the Midwest and the high plains of the United States. Okay? All right, that's chapter 4.